All right, let's just dive right into it. Today, we're acting as data detectives, learning how to uncover the undeniable mathematical truth hidden within raw data. I mean, we live in a world that is just constantly overflowing with numbers, right? But how do we actually make sense of them all without getting completely overwhelmed? Well, that is exactly what we're going to figure out today.
You know those bold headlines you see all the time? Things like, "Teenagers vote Diet Coke as the absolute best soft drink," or "The Beatles are officially the most popular band in history." Well, how do we actually know that? They didn't literally go out and ask every single teenager on the planet, right? No way. Determining if these headlines are actually true requires a systematic, structured data strategy. They used a process.
So, here's our game plan for today. We're going to cover collecting and sampling data, designing flawless surveys, sorting the chaos, the averages arena, measuring the spread, and finally, taming big data. Let's get to it.
Section 1. Collecting and sampling data.
Okay, since it's literally impossible to ask every single person in the world your question, or even everyone in a massive high school, we use what's called a sample. And as a golden rule, this sample needs to be at least 30 people to be mathematically reliable. If you ask fewer than 30, your results might just be a total fluke. But on the flip side, ask way too many people and you're just going to drown in the data.
Now, the absolute biggest trap here is bias. Bias is what happens when your sample unfairly leans in one specific direction. Think about it. If you want to test the idea that boys are taller than girls at your school, you wouldn't just measure the older senior girls and compare them to the tiny incoming freshman boys, right? That totally skews the results, right? You need a genuinely random sample where everybody has a totally equal shot at being picked.
Moving right along, Section 2. Designing flawless surveys.
All right, so you've got your random sample. Now what? You have to ask them the right questions. And looking at this breakdown, you can see the rules are actually pretty strict. Questions have to be short, super clear, tackle just one thing at a time, and absolutely never lead the person to a specific answer. A leading question is a massive red flag. Like if you ask, because of the global climate crisis, don't you think families should be banned from having more than one car? Wow, you are practically forcing them into a corner with that wording. Here's a massive pro tip for you. Always run a pilot survey first. Think of it like a dress rehearsal. You test your questionnaire on just a small handful of people to see if your wording actually makes sense to a normal human being. It lets you spot confusing questions and fix practical roadblocks before you launch the real thing.
Section 3. Sorting the chaos.
Okay, the survey is done. But now you're staring at a giant, messy list of raw numbers. What do you do? Well, check this out. By using a simple tally chart, drawing those lines and grouping them into fives with that diagonal slash, you instantly transform all that chaos into a perfectly clean frequency table. Suddenly, this random block of data about cars actually looks like a readable pattern.
And what if you're tracking two things at once? Say, the color of a car and exactly where it was manufactured. That's where a two-way table is an absolute game changer. It lets you cross-reference everything perfectly. And the absolute best part? It has a built-in safety check. The grand total you get by adding down the final column will literally always match the grand total you get by adding across the bottom row. If it doesn't, well, you know you made a math mistake.
Which brings us to Section 4, the averages arena. So the data is perfectly sorted. Now we have to find the center of it all. But we actually have different mathematical tools for different jobs here. The mean is what most people think of. You add everything up and divide by the total. But watch out, because one massive outlier, like one billionaire walking into a room of average earners, will completely skew the mean. That's when you bring in the median. The median is just the middle number when you line everything up in order. It completely ignores those crazy extremes.
But then there's the mode, which is simply the most common number. And as this quote points out, sometimes the mode is the only one that actually makes sense in the real world. Imagine you're managing a shoe store. If you calculate the mean shoe size of your customers and it's a 7.4, well, what are you supposed to do with that? You literally cannot order a size 7.4 shoe. You need the mode. You need to know which actual whole shoe size sells the most frequently.
All right, Section 5, measuring the spread.
Finding the center point is great, but it's really only half the story. We also need to know how wildly our data is scattered. Enter the range. The range tells us about consistency. You literally just take the biggest number and subtract the smallest number. A tiny range means your data is super consistent and tightly packed together. A huge range? Not so much. To put that into perspective, look at these cricket scores. Praveen has a couple of really high-scoring games, sure, but her range is a massive 9.
Her performance is completely all over the place. Medea, on the other hand, her range is only 4. Her scores are tightly clustered together. If you want a reliable, consistent player, Medea is for sure the safer bet.
And finally, Section 6, Taming Big Data.
Okay, things are about to level up, but stick with me. First, we have to completely understand the difference between discrete and continuous data. Discrete data is stuff you count in whole numbers, like the number of matches in a box. You can't have half a match. But continuous data, that's stuff you measure, like someone's exact height or the time it takes to run a race. It can be broken down into tiny, infinite fractions between any 2 points. Now, when you have an absolute mountain of continuous data, you usually have to group it into classes, like heights between 170 and 175 centimeters. But here is the catch. The second you group the data like this, you lose the exact individual measurements. So we can't find a single mode anymore. Instead, we look for the modal class, which is simply the specific group that pops up the most often.
Because we lost those exact numbers, calculating the mean gets a little tricky too. We actually have to estimate it. But don't worry, it's just a 4-step process. You find the exact midpoint of each group, multiply that midpoint by how many times that group happens, add all those results together, and then divide by the grand total.
Check out how it all comes together right here. By just adding a column for the midpoints, and then one more column to multiply those midpoints by the frequency, this massive, scary dataset becomes totally manageable. And boom! We get a highly accurate estimated mean height of 171.3 centimeters. It's honestly like watching a giant puzzle snap together. So what does this all mean for you? Well, you now have the tools to decode the actual truth behind the numbers. Next time you see a crazy headline with some wild statistic, don't just take it at face value. Ask about their sample size. Look for the hidden bias. Check if they use the mean when they really should have used the median. You are officially a data detective now. Thanks for hanging out with me on this explainer, and keep asking the right questions.